When you are working with, say, an Arduino or another mini computer, there are many of these mini computers on the World Wide Web, and they often work on 5 volts. So here I made a beeper that is perhaps usable for such a application. Of course also for other applications, no problems with that. And here is the setup. It's very simple, only consisting of 3 transistors, and I will show the schematic. Here is a loudspeaker of 8 ohms connected, the on-off switch, and here I have 3 more or less carbon zinc batteries in series, so they give approximately 4.5 volts. Well, this is the circuit. I hope it's visible of this distance. It's very simple. One transistor here, the second transistor here. This is an oscillator. The oscillator is driven out of its collector to an end transistor, more or less an end transistor. Of course, this is not a real end transistor, but anyway, it surely can work on this voltage, 5 volts, 4.5 volts, etc., etc. I did quite a few experiments this evening about this circuit, and I want to demonstrate it now. So this is how it is. You can set the frequency here, but you can also use a fixed value resistor here. No problem with that. Say 100k or 50k or 10k or whatever. Well, that's more or less everything to tell about this circuit. So I will switch it on now with the switch, and here we the frequency, and of course that's perhaps important to tell. The say frequency that we need here is a frequency that is most sensitive to the human ear, and that's between, say, approximately 1 kilohertz and approximately 4 kilohertz. So that's the frequency where this works, and well, could be very irritating to hear it during the video, but anyway, it's a demo. And you can hear this sound because the sensitivity of the human ear approximately for a distance of, say, 5 meters or 10 meters. And well, perhaps interesting to show that when you have wet fingers and touch the circuit, in all kinds of ways, this has everything to do with, say, the standard electronic phenomenon. Say, talking about stray inductance, stray capacitance, stray resistance, etc., etc. That's what I wanted to demonstrate. Anyway, the circuit is okay. You can use it with 3 batteries or 5 volts, and it's very, very easy to make. So here it is again. First transistor is an NPN transistor, second transistor is a PNP transistor. They make an oscillator. The frequency is in principle set by this the value of this capacitor, 22 nanofarad. You can go to a higher value, say 100 nanofarad, but of course the frequency will drop and also the amplitude, so the strength of the sound that you hear in your loudspeaker, out of the loudspeaker, will also drop. So 22 nanofarad was, in my opinion, a good value. Here the first transistor is given a kind of positive bias, and I found that I needed this resistor here to give the second transistor a good bias to make the circuit work better, and then I mean with enough audio output. Thanks for watching. This is all. I will pan over somewhat, switch it on, and of course we can look at the same time on the oscilloscope. Say, not very soft sound that you hear, but that is of course the aim of this circuit, because it's an indicator. You have to be, say, alarmed when you hear this sound. Anyway, here is the scope view. And well, it's a kind of square wave. Say, also with pulses, very small tiny pulses, and that makes it a kind of an irritating sound. Anyway, thanks for watching.